Now we need to talk about taking derivatives of trigonometric functions. So we start off just with sine and cosine, and then eventually we'll get into the other four basic trigonometric functions. So sine and cosine. The derivative of the sine function is the cosine function. Okay? And the derivative of the cosine function is negative sine x. Now the reason behind this is, again, to the limit definition. And so if we look at the limit definition for, let's say, sine, so our function f of x is sine x, okay? So what we'll need is f of x plus delta x, which is going to be sine of x plus delta x. Now, there's something called the sum identity that says if you're taking the sine of a sum, there's a way that you can break that down. And essentially what it says here is that this sine of x plus delta x will be equal to the sine of x times the cosine of delta x plus the cosine of x times the sine of delta x. So we're going to use that. And again, it's just a sum identity for sine function. And so what we're going to do is we're going to use our derivative definition that says we should have the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. And so in our case, this would be the limit as delta x goes to 0 of f of x plus delta x, which is all this, okay? So sine x cosine delta x plus cosine x sine delta x minus f of x, which was the sine function, all over delta x. Now here's what we're going to do. We're going to take this here and this here, put them together. They both have a sine function, so I'm going to factor the sine out of that. And I'm going to write it as the limit as delta x goes to 0 of sine x times cosine delta x minus 1 plus cosine x sine delta x. Oops. Sine delta x all over delta x. Then what I'm going to do is I'm going to break this apart and look at this over delta x plus this over delta x. What I'm also going to do is I want the order here to be reversed, so I'm going to factor a negative out, which will flip the order of these two around. So I'm going to have the limit as delta x goes to 0 of negative sine x times 1 minus cosine delta x over delta x, okay, plus cosine x times sine delta x over delta x. Now, delta x is going to 0, okay? X is not changing. X is just x, but delta x is going to 0. So this is really just staying the same. That's going to be a big constant multiple. This is where we have our delta x, but that's one of our special trigonometric limits. Same thing over here. Cosine x is staying cosine x. X is not changing. Delta x is going to 0. So here is where I have delta x. There's another special trig limit. So if you look at this, if you remember, the first one, this cosine one here, was equal to was equal to 0, and this other one was equal to 1. And so what we get here is minus sine x times 0 plus cosine x times 1. And this being times 0 is gone, and what do you have? Cosine x times 1. So the derivative of the sine function is this cosine function. And so, we don't have to do that every single time. What you're going to want to do is you're going to want to memorize that the sine derivative is the cosine. And the derivative of the cosine is negative sine. Okay, so something you're going to want to commit to memory is the derivative of these functions. This derivative basically comes about the same way. We use the sum identity for cosine, and the proof works very similarly. So we're just going to apply those two derivative rules to certain simple examples. Here's two of them. So here y equals minus 2 sine x. Minus 2 is a constant multiple. So if I'm going to take the derivative of y, I can pull the minus 2 out. I would then take the derivative of the sine function, which we now know is the cosine function. And that's it. Pretty simple. This over here, f of theta equals theta squared plus cosine theta. Same deal here. If I want to take the derivative of f with respect to theta, since these are added together, I can use my sum rule that says I can take the derivative of theta squared and cosine theta separately, theta being my variable here. So theta squared would be power rule, so I would get 2 theta. Okay, just pull the power out to the front, new power is 1. Plus, the derivative of cosine would be negative sine theta. So we would write our answer as 2 theta minus sine theta. Again, pretty easy. You're applying these new sine and cosine derivative rules along with some of our other stuff like constant multiple rules, sum and difference rule, power rule, etc.